Number 2. I want to remind you also that when it comes time for the test, I'm going to tell you guys to, I'm going to remind you to clear your RAM. But other than that, there is no help with the calculator. Today is it. You need to know how to put things in your calculator. Like number 1, last period they wanted me to go over that. If you get an error message, that's because you made an error, not the calculator made an error, okay? So I always have kids that start raising their hands and say, look, I put it in right and it's giving me an error. Well, if it's giving you an error, you didn't put it in right, okay? That's what that means. So keep that in mind. So if you have any calculator questions, get them answered today. All right, the directions are to factor this, okay? The first step of all factoring is to factor out a GCF. And there happens to be one in this problem. And there's a reason I gave you quadratic formula, and that is because if you tried to factor this using the chart method, it wouldn't work. You almost think it would work because what numbers multiply to get 5 and add to get 4? 1 and 5. So you might think that there's a chart way to do it, but the signs would be wrong. So if you need help with that, chat with me later, okay? But you have to be able to do quadratic formula here. A is 1, B is -4, and C is 5, okay? So I'm just going to plug right into quadratic formula. Remember, when you plug a negative in where there's already a negative, you change it to a positive. 2 negatives make a positive. And what I'm seeing again and again and again, let's get this out of the way right now because you're going to have to square lots of numbers in your life, that a lot of students are still not realizing that when you have x squared and you plug a negative number in there, the negative and the 4 are what x is, right? You're squaring whatever x is. You have to square the whole thing, the negative and the 4. So this is like one of the most common mistakes I see here. And then they're like, the answer's not there. You can see I did all the work right. Look, I did this. Look, my calculator even says. When I do that math, I get a -16. Remember, your calculator is doing order of operations. It's squaring the 4, we do exponents first, and then multiplying by a negative. So that's 16 times a negative is a -16. But that's not what we are supposed to do. So let's not put it in the calculator. Just know that when you square anything, you either have 2 positives, which is positive, or 2 negatives, which is positive. You're always going to get a positive number. And then -4 times 1 times 5 is -20. Oh, I forgot about all over 2a, 2 times 1, okay? So then we go down and we have 16 minus 20 is -4. The square root of 4 is 2, so the square root of -4 is just 2i, right? And this over 2 is divided by 2. We're dividing both of these by 2, okay? To simplify, and you get 2 plus or minus, and 2 divided by 2 is 1, and we never put a 1 in front of a variable. So that is successfully completing quadratic formula. Before we go to that final answer, anybody have a question about any of my steps in there? Please don't be shy. This is your time, okay? So if I went too fast, you missed something, tell me, interrupt me. I don't mean that in a rude way. You're not interrupting. I want you to tell me if you need something. Okay. So guys, understand, quadratic formula solves for you. These are the solutions to this quadratic. We don't want solutions. We want factors, okay? So we have 2 plus I, we have 2 minus I. Those are the 2 solutions. To write them in factored form, all you're doing is bringing these 2 to the other side of the equation. Just using your normal rules of solving equations, which are whatever operation, you just do the opposite. So I would subtract 2 and subtract I. I would have x minus 2 minus I, right? Minus 2 minus I. And over here, I would have minus 2 plus I, right? It looks funny, and some of us struggle with that, all right? But all you're doing is just like you would with this, how do I change this solution to a factor? You're just subtracting it, bringing it to the other side. It's the same idea. Anything that's on the right side comes to the left side, opposite operations. Don't forget that we factored out an x to begin with, so this would have been choice A. Okay? Factored forms should all be parentheses. Even if you didn't read the directions carefully, always look at the multiple choices. Okay? Multiple choice questions are gifts. They kind of guide you to what your answer should look like. Well, they do. They tell you what your answer should look like. Okay? Any questions on number 2 before we go to 10? After number 10, it's open season. Anybody who has questions, I will just answer. Oh, I forgot. Actually, before I do this, I have a gift for you by doing another example. This example, you can just watch me, you can write it down, but I'm kind of giving you a hint here. You could get a problem like this for number 2 as well. Okay, so number 2, you could get a problem like this where it says factor completely. This is a little different looking than the review question that's on your review. There's no GCF, but it looks really similar to a type of polynomial that we are really familiar with, and that's a quadratic trinomial. This is a quartic trinomial. And I showed you guys this on that day. It's been a while, and we do a lot in this class. You can actually factor a quartic trinomial with our chart method. Here it is. 1 times 8 is 8. Middle term is 6. What 2 numbers multiply to get 8? Add to get 6. Right? If it were this problem, your answer is x plus 2, x plus 4, right? In any order, you'd be done, factored. This one has one little step that's different. X squared plus 2 and plus 4. Is there any, and you always want to ask yourself, is there anything else I can do? And the answer is no on this one, okay? Look. If this were a negative, just to make sure you remember this, if you had an x squared minus 4, you could write that as x plus 2x minus 2. You can't do that with the plus, okay? So always look to see if there's anything else you can do. In this situation, that would be the final answer, okay? So I wanted to remind you of that. I'm being really, really kind to you in this first test. I'm giving you lots and lots of hints. Hints. Okay, back to number 10. So the directions for number 10 are solve. Solve using sign analysis, sign chart. Okay, the first step is to factor. To factor a polynomial, all the terms have to be on one side and a 0 on the other. And the terms that are on one side together should be written in standard form. What's standard form? What do I mean when I say that? Our exponents should be in descending order, biggest to smallest, okay? So x to the third would be the biggest one. Guys, I hope you're paying attention to all this because there's lots of little places I'm pointing things out, common mistakes, where I know people have made mistakes in the past. So I would not be working on anything else right now. All right, subtract 3x, subtract 6 gets us here. So my exponents are in descending order. This is standard form. Okay? Now, how do we factor a poly of 4 terms? Hey, guys, can we not talk? You would do grouping. You don't have to listen to me. That's fine. You feel super confident, but let's make it so that everyone can hear and not listen to you guys talk. Okay, so I did 2 and 2. GCF of these two would be x squared. That leaves me with x plus 2. Remember, anytime the first term of a parentheses is negative, the GCF is negative. Ouch. Hurt. And so that would be a 3, and that leaves me with x plus 2. Remember, your goal here is to get identical twins in the parentheses. So my identical twins can go in either one, doesn't matter, right? That's the x plus 2 and the x plus 2. And then the GCFs go in the other one. And there's nothing else I can do to factor this, okay? This is completely factored. So The next step is to find the critical values. Your critical values are just the zeros of the function. The zeros are your solutions. If I set these two equal to 0 and solve, those are the zeros. Okay? So this one's pretty easy. Set x plus 2 equal to 0 and solve, you get negative 2. Right? If I set x squared minus 3 equal to 0 and solve it, I would get add 3. And this is not work I would need to see on a test, okay? Don't forget, anytime you take the square root of something, you get 2 solutions. Remember, if you're degree 2, you should have 2 solutions. That's where the plus and minus come in. Now, what the heck is the square root of 3? So we have to put that in our calculator. I just did the square root of 3 right in my calculator, and I rounded it to 1.7. Why is that important? Well, because I have to make a number line right now and put my 3 solutions in order from least to greatest, okay? So understand, this is like an x-axis of a graph, okay? And I would put on there, in least to greatest, my 3 solutions. So if I graphed this, this is where the graph would touch the x-axis. What the question is asking for is where are we below the x-axis. So when we do our sign analysis, we'll be looking for anything that's negative because it's less than, okay? But before we get to that, we have to find test values. You can pick anything you want less than negative 2. It doesn't matter. Pick anything you want. Remember, this is negative 1.7, so we're going to have to pick a decimal. As long as it's between these two, it doesn't really matter. Negative 1.8 is what I chose. Anytime I can use a 0, I like to use 0. So if we have a negative and a positive, right between them is 0. And then anything greater than 1.7, like 2, like 5, like 105, it doesn't matter. Okay? The next step is where I saw some people getting stuck yesterday. Like, what do I do with them now? You plug back into your last factored step. So plug right into there. And all we care about is a sign, okay? Negative 3 squared is positive 9, and 9 minus 3 is positive 6. So I get a positive with this one. And then negative 3 plus 2 is negative 1. I get a negative. When I multiply a positive and a negative together, I get a negative. So like for my sign chart, this is my final answer, this right here for this interval of negative infinity to negative 2. Okay? Odd number of negatives, always negative. We've talked about that a lot. So, you know, it's a calculator problem. What's 1.8 times 1.8? 3.24. So when I square negative 1.8, I get 3.24 minus 3 would give me a positive answer. Negative 1.7 plus 2 would also give me a positive answer. And you can use your calculator if you need to. 2 positives make a positive. Plug in a 0. 0 squared is 0, minus 3, negative. 0 plus 2, positive. Odd number of negatives, we're negative. And then finally, 2 squared is 4, 4 minus 3 is 1, that's positive. 2 plus 2 is 4, positive, so we get a positive. Okay? So the question is, where are we below 0? Anywhere we have a negative, we are below 0. So now we write our final answer. From left to right, negative infinity, all the way up to negative 2. Are we going to put brackets or parentheses on the negative 2? Parentheses, actually. Remember this rule. If it's a less than or a greater than, it's parentheses. Regular old interval notation, guys. If it's included, meaning equal to, that's when you use brackets. So this would be parentheses, and it matters. It makes a difference. And then we would also have from negative square root of 3 to the square root of 3. Okay? Questions on 10? All right, open questions. Ask. What can I do? Lincoln? Okay, I'm going to go over number 1, which is all those calculator ins and outs. Listen, I'm going over the calculator stuff. Clear your RAM. Right there. So clear your RAM, guys. Make sure you do that. I already had whole footage it for you. Oh, okay. All right, guys, here we go. Remember, number 1 tomorrow is going to be a calculator problem. You're going to have to do this. You raise your hand, I'm not going to be able to help you. You have to know how to do it on your own. All right? So it's asking for which of the following statements is true. And so always look at your multiple choices before you start. We're talking about mins and maxes. You know, one thing you could do always, and as we get closer to the AP exam, I'll be giving you lots of tips like this. But if you're like, how do you know where to start? Like, you've got 4 choices. You don't want to waste time, right? You don't want to waste time. So how do you narrow it down a little bit? Okay, we've got mins and maxes. Oh, let's put it in our calculator first, then we can look at the graph. Okay, so let's put this in our calculator. Y equals, here's my RAM. So you want to clear your RAM, and then you're going to go up to Y equals. Number 1 mistake students make on this problem is mixing up the negatives and the minuses. It matters. You cannot interchange them. Okay? So how do you know which one? Read it to yourself. We would read that as negative x to the 4th. That's why we would use the negative button. Negative x to the power of 4. Don't forget, you put your cursor up there. It's staying there till you tell it to move. So you would right arrow that. Minus x to the 3rd. Move it down, plus 6x squared. Okay? Anybody have a problem with just that step? No. Okay, graph. So this is where you would look and say, okay, looks like there's a maximum that I can't see. There's another max. So I have 2 maxes and a min. All right. Is there anything I could eliminate? And so just for time's sake, look at your 2 minimums, okay? Do we have a minimum between 0 and 2? No, we have a maximum in between 0 and 2. Do we have a minimum between -3 and 0? No, there's a maximum between -3 and 0. And maybe you could even pick your answer at this point as B. But let's keep going. So one thing that we need to be able to do is see where that turning point is. This is called a window. If you want to change what you're seeing, you go to the window button, okay? Because as you know, the calculator just goes in goes in every direction 10 units, okay? So anything that has an x associated with it, it has to do with the x-axis. Anything with the y has to do with the y-axis. So if we want to go up, we have to change the y-axis. And so I'm going to go to where y max is and change it. Pick something. There's no wrong answer. Pick something. If you still can't see that turning point, then you can always go back and change it, all right? So pick something. As long as you can see it, you're good. All right, now I'm going to go to my menu called Calc. That's where you can see lots of different characteristics of a graph. I'm going to start with maximum, and I'm going to hit number 4. Okay, so to maneuver through this graph, you only use left and right. That's all you need. So right now my cursor is at the origin, and there's a cue, but it's cueing you right here. It's asking for the left boundary. All that means is they want you to set a boundary, a bound, on the left side of whatever point you're talking about. In this case, it's this absolute max right here. So I would hit enter. Then I would arrow over and get my right bound and hit enter. It can be anywhere to the left, anywhere to the right. There's not one place that you can set your point at. It's always going to say yes. You hit enter one more time, and it tells you there's a maximum at that ordered pair, which is how we got there's a global minimum between -3 and 0. Does that make sense, Lincoln? You good with that? Anybody else have a question about that one? Zoe, do me a favor and speak it up. Are you talking about let me see. When it looked like this. Okay, so I did. So you knew how to change the window, right? Okay, so now we have this. So where do I go to find max and min? It's the calc menu. That's blue above trace. So I hit second trace or calc. And that, is that where you were talking about? Yeah. So, and then number 4. And then you just move left and right. All right, more questions. Do we all know the midpoint formula? I'm not giving it to you on the test. Let me talk about this. I'm going to give you guys some hints about this FRQ. Guys, FRQs are harder. Shh, listen. FRQs, you don't have multiple choices guiding you. You have to use all the correct notation. One thing you have to notice is, guys, even if you don't read word for word, you should skim those directions. Over and over again yesterday, students missed that the points P and Q were given to you. My advice, not required, is to label the graph with anything that's not already on it. It just makes answering lots of questions easier. So this is point P. It was given to me. Point Q, 2.6, 12.4 was also given, okay? So let me just quick, I'm going to go over, there's a few of these that second period asked about that were really good questions, so I want to give you guys some of that information. The domain of a polynomial is all real numbers. No matter what direction the arrows go in, all polynomials are all real numbers, also known as negative infinity to infinity, okay? The range is not all real numbers on this problem at least, okay? We read a graph left to right when we're talking about the x's or intervals. We also read the graph bottom to top for range. We want the least to greatest. Since both arrows are pointing down, we know it's going to go down forever. But it doesn't go up forever. This is our highest point. The y value of our highest point is 12.4. Am I going to put parentheses or brackets on that? Does it matter? Yeah, 12.4 is part of the graph. It is a point on this graph. You have to include it. It is a point, okay? So, reminder about that. Parentheses and brackets matter, order matters, okay? Points of inflection are, remember, where the concavity changes. How do you know how many there are? Your turning points minus 1. So there's 1, 2, 3 turning points. You're going to have 2 POIs. What the work is to show on that is the plugging in for B and number 8. Same exact work I'm about to show you. So in letter B, you're finding the midpoint between these 2 points and these 2 points, right? There's a change of concavity in between these 2 and in between these 2. That's where you use the midpoint formula. Guys, if I told you that your final grade in this class was just 2 tests, that's all I'm grading. It's 2 tests and the average of those 2 tests. You have a 90 and an 80, you would add them together and divide by 2. That's an average, right? Add together, divide by however many you have. All a midpoint is the average of your x's and the average of your y's, okay? You're adding your 2 x's together and dividing by 2. It doesn't matter which one you call the first and which one you call the second. The y values of those 2 points, doesn't matter which one's first, which one's second. Find the average of the x's, the average of the y's. That's the midpoint, okay? So the work you would show for this is this. So if I'm going to do these 2 first, and it doesn't matter, let's do these 2 first. That'd be -3 plus -1.2 in any order divided by 2. And then my y values, looks like 9, no, that's a 0, sorry, 0 plus -1.8 divided by 2. I don't need to see any other work. You could just write your final answer here, okay? That's the work. And then you would do the other 2 points. -1 plus 2.6, any order. 12.4 plus -1.8, any order. That's the work, okay? Go to your calculator, get your answer, okay? So that's the same work you would show for number 8. right here. Any other questions about that one? And one more that I want to make sure I go over, then I'll, again, open it up to you guys, is part C, identify any absolute. So absolute, same as global. Absolute highest point versus absolute lowest point. Well, if you have arrows both pointing down, you can't have an absolute minimum, okay, because it's always going down further. But in this graph, you do have an absolute max. Listen, so people that aren't paying attention are going to probably get this wrong tomorrow. You need to tell me what it is. You can't just tell me, oh yeah, it's this ordered pair or whatever. Because you could write it as 2.6, 12.4 if you wanted to, and I'll show you the other way to write it. But you have to tell, what is it? Is it min or is it max? So you would make sure you tell me what it is. Extrema covers mins and maxes. What do we have? We have an absolute max at that point. Or you could say you have an absolute max value of 12.4 at x equals 2.6. So we saw that a lot in our homework way of writing it. I would accept this as well. Okay? But you have to show that. Now look, guys, if you had a graph that goes like this, what is this? Do we have any absolute extrema? No. In this situation, you'd say none. Okay? If you had a graph that goes like this, you would not have an absolute max, but you have an absolute min. Okay? So you have to, every graph is a little different. You have to look at that. Okay? Yeah. Mm-hmm. This right here? Oh, that's a negative 1.2. Sorry about that. Thank you. No, thank you. Yes. I don't know why I use zero. Listen to me, guys. You need to look, because I can see now why zero is questioning me. So number 14 was also a problem. Right, do that. Then 2.2 stay one more. That would have been even slower. 1, 2, 4, 9, 20. We didn't do that. We did one problem, so I give you a 1. I'm going to leave you full credit. And you're working so hard to really happen. But we're going to get better. Okay? All right. So listen to me, guys. Please listen. If you paid attention during that points of inflection thing, I messed it all up. Okay? Thank you for catching that, Zoe. Way to confuse you. Guys, these are the 2 points. This point and this point is where I should have been doing this one. So I did this one okay? Yeah. No. Oh, okay. No, I did do that one okay. All right, that one was okay. And then I should be doing this one and this one. So that would have been negative 1.2 plus 2.6 and then 12.4. Okay, so it's just that 1.2 that I messed up? Okay. All right, so everyone... Oh, sorry. Okay. Anybody need any more explanation on the points of inflection? Do you want me to do number 8? You raise your hand if you want me to do something. I'll do it. I'm your math slave. Yeah. Sure. Okay. So if you have 2 turning points, we have 1 point of inflection, which makes sense because it's multiple choice. There's only 1 in each choice. So what we're going to do is find the midpoint between these 2 points, right? Because this is where we change from concave up to concave down, somewhere in here. Does that make sense so far, Connor? All right, so I'll be really careful here. I take my x values and add them together in any order. It doesn't matter. So this is the work you would show. -2 plus 3.25 or 3.25 plus -2, either order, divided by 2. Why divided by 2? Because there's two numbers you're adding together, always. Okay, and then you take your y values and add them together in any order. 4.25 plus -6.25 divided by 2. That's the work you would show. And then you just put it in your calculator. Are we good after that? And you'll have a lot more room tomorrow, guys. It's full sheets of paper, okay? You won't have, like, all scrunched in. You should have plenty of room to show your work. This is it. You'll have 10 multiple choice and an FRQ that looks just like it. When I hand you the test, you're going to almost think I gave you the review as a test. Because it's the same. I don't even shuffle the questions, guys. I kept it in the same exact order. You know number 1 is going to be calculator min-max problem. You know number 2 is going to be factoring using quadratic formula or a chart. You know number 3 is going to be AROC and so on. Okay? So if you did this and took it seriously, you should be at that high end of the grading scale for sure. No tricking you. I'm not a trickster. More questions? On E? Let's see. That's a great question. You guys listen to what someone asked. On what intervals of the domain is the graph concave down? Let's pretend it's this question that we're talking about right here. Well, it's going to be very clear if you got B right. Because remember, your ordered pair here is that point where concavity changes. So the answer here was -2.1 to -0.9. So listen, the first place where we're concave down would be from -infinity to whatever the x value is. Sorry, I know I've made a mess of this graph. Let me get a fresh one. Where I am concave down would be from here to somewhere in the middle here, right? Do you agree with that? That's one of them. So when I go to answer part E, I would say -infinity to what? Do you remember that quiz we had? We had to like kind of look at the number line. It was like we had to like name it. We don't have to do that here. We already found that point of inflection, which is right here. We found it. It's -2.1 to -0.9. So I know exactly what to put here. Now, what if you got this wrong? What if you had -8.7? Okay, let's pretend you had this wrong answer. If you wrote -8.7 here, you would still get this right. Do you see what I'm saying? So if you did your math wrong up here, but you're saying, oh, I think the x value of this point is -8.7, you're telling me you knew where the concavity changed. Do you see what I'm saying about that? I mean, you would get this part wrong because you did the wrong math, but you get that wrong. Right. And then the other concave down would be somewhere in here, right? So from somewhere to positive infinity. Okay, what is that point? That's the other point of inflection that we found here, in between. So that's a really good question. So there is an actual number that you would use for that. Okay, does that make sense? Yeah. Yeah. Oh, I don't care. Yeah, there's a lot of things that I'm not picky about. Like, if I'm picky about it, like, I keep emphasizing it. Annoyingly so, right? There's certain things I say all the time, and you're probably like, I get it. But I've said you can put a comma, you can put a U. Don't put anything. I don't care. Yeah. Say it again. Sorry. Deep? Okay. Increasing or decreasing. Guys, you can use parentheses or brackets. Okay? Doesn't matter. Where are we going up? Where are we going down? So we're increasing. Guys, look. It's like a double question. You're going to have to tell me where we're increasing and where we're decreasing. Just like I did on my key. If I wrote something on my key, it's something that I'm picky about. Increasing and decreasing. So we're going up here. That's from, an interval is x-axis. I'm almost done, guys. Hush, hush, hush. Negative infinity to -3. Where else am I increasing? From 0 to whatever the x value was there. No, that's not 0. Sorry, that's that -1.2. Where am I? To whatever this was 2.6. Michael, is that good so far? Okay, and then decreasing, of course, would be from this x value to this x value, this x value to positive infinity. Yeah, make sure you tell me. Don't just write a bunch of intervals. I don't know if you know if that's increasing or decreasing. I model for you what I expect you to do. Okay? Anybody thinking of anything else? Yeah. For the first one, the bell schedule for tomorrow is over there if anybody wants to